In this problem, we are given two binary images. So by binary, we mean that their pixels are either 0 or 1 values, and these are square images. So width is same as height, and we have two images. So you can see one of them is A, one of them is B, and you are allowed to shift one image over other. You can also keep it exactly here. So that will be the initial step. So B is imposed over A, and there will be some 0 values. There will be some 1 values. So if you overlap this one over this, you see if 1 and 1 overlap or not. So we have to count what is the maximum such possible overlap and what operations you are allowed to do. So initially you overlap A and B together. You count how many of the ones are overlapping on top of each other. That is, if there is a 1 in 0, 1 position in A, and without doing any shift, if there was a 1 in 0, 1 of B also, then you would count that as 1. But you are also allowed to shift it. So you can shift it in the direction of down, right, up and left. So that again here this part is overlapping. So whatever is not overlapping, you don't consider that. But here let's say we have 4 ones, and in B also at this position we have 1, 1, 1, 1. And so you see that here we have 4 overlaps. So maybe for this case 4 was the maximum, so you will return 4. So you are allowed to do as many translations as possible. So you can slide it left as many times as possible. Obviously once it goes out of this image, there is no point in trying further. It will always be 0. So you will slide to the right by at max n minus 1 step. Similarly, you can slide in the bottom by at max n minus 1 step, or top by n minus 1 steps and left by n minus 1 steps. And you have to find the maximum among all those overlaps. So overlap only means 1 and 1 overlapping. So that is, you multiply, you do element wise multiplication of the overlapping region. So obviously 0 will become 0. 0 overlapping with 1 will also become 0. So only if both are 1, then the result will be 1. So let's see. So in this example, I will represent image A by this light blue color and image B by this transparent image with yellow boundaries. And let's say we have 4 cross 4 for this example. In general, it will be n cross n. So what we will do, we can keep one of them as fixed. So that is the problem statement, and you will overlap B on top of it and then slide B as much right as possible and as bottom as possible, similarly left and up. So let's see. So here we have, so we will first take the overlap with A and B exactly overlapped. That is, if let's say we have 1 here, 1 here, 1 here. So these are 1s and others are 0. And in B we have, let's say 1 is here, 1 is here, here it's 0, here it's 0, here it's 1. So you see the overlap will be just this one. This is at the same position, and this one. So without doing any shift, the max overlap is 2. Now this is our initial state. Next what we will do, we will only shift in the x direction. So this is for y shift equal to 0. So you can think of it as y shift is 0 and x is varying from 0 to 3. We will not shift more than 3. There is no point in that. So here we shift by 1. So what will happen? So let's see. These 1, 1, 1, 1 will remain same. And here it was 1. So it goes out of scope, and here it was 1. So this is after x equal to 1, y equal to 0. This is after x equal to 2, y equal to 0, x equal to 3, y equal to 0, and by x we mean x shift. Next, y is 1. We shift in this direction also, and x is 1. This is y equal to 1, x equal to 2, and this is y equal to 1, x equal to 3. And the next one will be, this will come here, y equal to 2, then y equal to 3. So all possible shifts we have made, and in the last one what will happen? This will be like this. Just one cell will be overlapping. This is 4 cross 4. This one. After that, if we make any further shift, none of the cells will overlap. So we see in all these configurations what was the overlap, that is 1 and 1 matching in this region. So here this is just the only region, here this is the only overlap. So let's understand how we will write this code. Understanding this is trivial. You can do all the shifts. So we have done X and Y direction. What will be the other two possibilities? Left and right, left and up. That will be equivalent to keeping this image stationary and moving this bottom and right. So those are 4 cases. Next, let's understand. So let's say we have this and there is a 1 here in both of them. So let's say black denotes the 1 in this one, and we will write in red, or not so visible, let's write in green. So this green denotes 1 in this B, and black one is in A. So now A, what is this row? This is 2 and this is 3, assuming we are starting from 0 0. So A 2 3 is 1, right? And we have shifted in X direction by 2. So X is 2, and in Y we have shifted by 1. So you can take any general X and Y. Here we are taking 2 and 1. So here B, this value is 1 1 is equal to 1. So when these are satisfied, then there is a count will increase by 1. So what are these values? Let's say these are general. So now let's generalize. We are looking at Aij. When Aij is 1 and shift is, let's say, X and Y. In the X direction by X, Y direction by Y. Then B, what is this? This is nothing but this value minus X minus Y. Why? Because we have, if we put it back, we will have to move it left by 2 units and up by 1 unit. So this is B I minus Y and J minus X. So when we are shifting in X direction, row is not changing. For example, you see first, second and third. Here X is not changing. X is Y is 0. So when Y is constant, columns are changing. So when we are changing in X direction, columns are changing, and when we change in Y direction, for example in these two, then row will change because we are shifting in this direction, so it will go to the next row. So that's why here in I we are subtracting Y, because changing Y changes the row. First one is row and here X. So this is the general case. So this we have to use in our code. So for shifts, how to take all the cases? X will be from 0 to n minus 1. Then in the next loop, we will have Y equal to 0 to n minus 1. So these are all possible shifts. And then here what we will check? We will check, we will iterate through all the pixels of A and B. You can iterate through one of them. Other one we can get from this relationship. X and Y we already have. So let's write it again. So X equal to 0 to n minus 1. This is our first loop. Y equal to 0 to n minus 1. Second loop. And what was this loop for? This was for shift, all possible shifts. So you will see that we are only shifting in right and bottom, and we are not shifting in left and up, because that is equivalent to fixing second image and doing the same shift in A. So either you shift A and B are overlapping, and let's say we shift B in this direction, right direction. This is equivalent to shifting A in left direction. The overlapped region will remain same in both the cases. So we have just defined shift in right and bottom direction for simplicity. And in one case, we will keep A fixed and shift B. In other case, we will keep B fixed and shift A. So we will account for the other two cases. So these and these loops are for shift in X and Y direction. Then we have to iterate through all the pixels of one of the images. A is fixed, so let's I equal to 0 to n minus 1. This is all the rows of A. Then j equal to 0 to n minus 1. These are the columns. So here we are iterating through pixels of the image, binary image. And here what we will check, A, I, j, whenever A, I, j is 1, then only there is a possibility of overlap, otherwise why would there be overlap? So now we find A, I, j equal to 1. Then what we will need to check, so if this is the case, then if B, I minus y and j minus x is also 1, then increment the count. So we will keep a temporary count here for this shift. For each shift we will have a count. So we will define a variable here, temp equal to 0. So we will do temp plus plus. You can merge these two conditions into one. If this and this, then temp plus plus. Now this is the overlap for one shift X and Y, and we will have a global counter. So after this one shift we will check count equal to max of count and this temp. That way we will check all the shifts and the global maximum, and we will need to call this function whatever we have defined 2 times, once passing A and B, next time passing B and A, to account for all the 4 shifts. So let's write the code for this. If you understand this, then you can write it very easily. So we will define a function called shift and count. So these are the loops for shifts. Now this is the temporary counter corresponding to this X and Y pair, X and Y shifts. Now we will iterate through this image. And no need to iterate this complete thing. We can only start iteration from here to here, from this point. So from this point till this point we are looking at image A. No need to look at these pixels which are not in the overlapping region. Only this part overlaps. And what is this value? This value is exactly X and Y. So this coordinate is X, Y, and this coordinate is as usual n minus 1, n minus 1. So this is one optimization. So if you start from here, anyway this I minus Y will go out of bound, so you will need another bound check, so better start from here. So we will start from X and Y will start from, J will start from Y. So in one case we are keeping A fixed and shifting B in right and bottom direction, all possible values, and in the other case we are keeping B fixed and shifting A in right and bottom direction. So shifting A in right and bottom means shifting B in up and left. So that's why these are equivalent cases. So there is some error in unsigned offset overflow. So I is the row number, and we have made some mistake here. So here row number is this Y. Okay, so this is the error here. So you see this is the shift in Y direction. So this will be Y. So this coordinate is not XY but YX. So you have to be very careful here. So shifting in Y changes the row. So it's slightly opposite. So this we need to change here. I starts from Y and J starts from X. Now it works. So let's submit. And the solution is accepted. And we are right here around 94% of the submissions. So it's good. So what is the time complexity overall? Let's analyze. So we have 4 loops. This is from 1 to n, and these are also not exactly n, slightly lower, but it's of the order of n square only. So overall it's n raised to the power 4 if n is the width, one of the dimensions, not the number of pixels but just width. So it's of the order of n raised to the power 4 time complexity, and space is O of 1. We are not using any extra variable apart from some small variables, so it's O of 1. Now let's write the same thing in Java and Python. And the Java solution is also accepted, and here also it's good, 88% of the submissions. Now finally let's write it in Python. So let's name it AA to differentiate from this so that there is no confusion. So here we are unnecessarily making some copy here, so you can try to avoid that by modifying this code, but let's keep it for simplicity. And the Python solution is also accepted.